So equivalence is an operation that we apply to propositional variables to determine if the value in those variables is the same or equal. So we're going to draw a truth table for two propositional variables. Let's call them P and Q. Because each one of the propositional variables can take on one of two values, and because I have two of them, that means that there are four possible combinations that these two propositional variables can take on. So I'm going to organize it in a certain way. I'm going to say that we'll put the true and true under the P column and then follow that with false and false. My Q variable, I'm going to toggle between true and false, true and false. These are all four possible combinations that I can have given two propositional variables. The third column is going to be the output of the operation that I'm going to perform. So what we're going to do is we're going to see if P and Q are equivalent. The symbol that we use is the equal sign with arrows pointed in both directions. Now, the idea is to determine if the P and Q contain the exact same value. So if I look at the first row, I can see that the value for P is true and the value for Q is false. Because they both contain the same value, the output or the equivalence operator is going to be true. If I look at the second row, I can see that the P is true and the Q is false. Because they are not the same, I'm going to put a false in the third column of my truth table. We'll move to the next row. The P is false, the Q is true. They are not the same, so I'm going to put a false. And if I look at my last row, I can see that both P and Q are false. That means that they both contain exactly the same value, so I'm going to put a true in the final column of my truth table. This truth table can tell me very quickly that the only time that the equivalence is equal or the same, or should I say true, is when both P and Q are true or when both are false. We are looking for instances when they are equal, and that will occur when both P and Q are true or when both P and Q are false. So what if P and Q are the propositional variables contain the truth value of a couple of plain language statements, such as, let's say we have a proposition called A that says I go to Weber State University, and proposition B that says I drive a Jeep. So P is the truth value of my proposition A, and Q is the truth value of my proposition B. Then we can say that equivalent is equal to the logic operator of if and only if. If and only if is represented by IFF. That means if and only if. And we can say that these plain language statements are true. I go to Weber State University if and only if I drive a Jeep. So this is the plain language way that we can represent equivalence among two propositions and their propositional variables representing the truth values.